Uh, Bismillahirrahmanirrahim. Assalamu alaikum and good morning to my students. So today is our math class, and we are continuing with the probability nowadays. So my dear students, our topic today will be independent and mutually exclusive events. So for the first, it is independent events. What are the independent events? Independent events. So independent events, if you flip up a coin, you will notice that either head will appear or the tail will appear. For example, I say when I flip the coin, the head has appeared for the first time. Head has appeared, okay, in the first throw. First throw gave me head, and the probability of head, you know what is the probability of head? It is 1 by 2 because there are two outcomes in total. There are two possible outcomes in total. The favorable is maybe, you can say that this is a favorable. Okay, 1 upon the total of 2 is the total of uh, the two faces of the coin are 2. Okay, so 1 will appear at the time. So 1 by 2 is the probability that head will appear. Okay, what about the second throw? Can I say that head has already been taken, so head will not appear? No, it is not possible that head will not appear. The head has an equal chance of appearing again. The head has an equal chance of appearing again, and in the first throw, the tail has also an equal chance of appearing for the first time even. You followed my point that each event is independent of the other event. Each event is the independent of the other event. That if head has appeared, it means it has nothing to do with the second event. Or second event, if head has appeared or the tail has appeared, it has nothing to do with the first appearance. So you cannot say that head has appeared for the first time, then it is not possible for the head to come to show its face again on the second throw. That is not possible. Okay, now we can say that first throw and the second throw are independent of each other, and they have nothing to do with the first or the second event. So these are called the independent events. So that means if this is A and this is B, if this is A and this is B, so what is the probability of independent event? It is A happens and then B happens. A happens and then B happens. So this line will show you that A has nothing to do with the B and B has nothing to do with the A. They are simply independent of each other. They are simply independent of each other. Once I'll repeat my words again, that for example you have come across with head in the first event, and it is not possible that you just say that head will not appear in the second event. Head will not appear in the second event because it has already shown up. It is not possible. The head has an equal chance of coming again. The head has an equal chance of coming again, and similarly, for the first time, the tail has also an equal chance of showing its face. Okay, so these events, these two events will be called independent events. And how we will write it? This will be written like this: P of A multiplied by P, or you can say cross P of P. P of P. Now there are two things, or and. Or and. These are very important two things. Let me write it over here. Or and. These are two very exclusive words which which are used in probability and in physics also. If I would have been teaching physics, just I do when these two words will come, I'll show you. But for your general knowledge, I'm going to just tell you what is or and what is and. For example, this is a bulb. For example, this is a bulb and this is its switch. This is its switch as we have in our homes. As we have our in homes, we just uh, put on the switch and the bulb lights up. And the bulb lights up. Okay, no problem with this. No problem with this. But what if I have two switches in parallel for the same? Just suppose that the supply is somewhere. Now this is a simple circuit, my dear students. You see that this is the hotline and this is the neutral, or you can say this is the phase and this is neutral. So always the phase is given in the switch. Okay, now there are two switches, S1 and S2. S1 and S2. You notice that, for example, if I just put on my S1, the electricity will flow from here to here and it light up the bulb. Okay, light up the bulb. Okay, because neutral is separately given over here. And if I just open this and close this, now these both are at the open stage at the moment. The both are at the open stage at the moment. For example, if I just close this, if I just close this, the current will flow from here and okay, our light is okay. Light has our bulb has lit. Okay, now I just close this again. I I open this again and close this one S2. You see that the light will not cross this barrier because this is open. Okay, now the current will flow from here to here and light the bulb again. Okay, now that means now this switch and this switch are independent of each other. This switch or this switch are independent of each other because either one of the switch will operate, the bulb will light over here. The bulb will light over here. Okay, and if both are closed, the bulb will remain lighting. Okay, the bulb will remain lighting. Okay, it means that if one of the switch is closed, if one of the switch, you see this is closed and this is open, this is closed, this is open, the light is okay. Okay, and if this is open and this is closed, the light will okay. But only the bulb will not light here when the both are open. When the both are open. So this is called OR. You can say it that this circuit is called an OR circuit because either S1 or S2 will close. Either S1 or S2 will close. The bulb will light, but in a different uh, thing. You see that if I put this in like this with two switches like this. Now this is neutral and this is again phase line. This is line. So you see that this is S1 and this is S2 and this is S2, and if I close this one, the light is will the current will not flow from here to here, because this is open, because this is open over here. And it is essential, it is imperative to close both the switches. It is imperative to close both the switches. So I have to close both the switches to get it operated, to get this bulb operated, energized. Okay, so that means S1 and S2 and S2. Or you see that what is the difference between here, that or you either you close this switch or you close this switch. But in this circuit, you have to close both the switches to get it energized. Okay, now same is the difference over here, or and. So when there are independent events, we use or statement. Okay, now what is the mutually exclusive event? Which are the mutually exclusive event? If you can say that you have, for example, you have a die and you want to roll it, you just roll the dice, and what is in your mind, that an even and odd number appears, and even and odd number appears. Is it possible that both even and odd numbers appear at the same time? For example, now this is a dice. You want it that an even and odd number appear at the same time. It is not possible, my dear students. It is not possible to have an even and odd number at the same time to appear while rolling the dice. So these are called mutually exclusive events, which are called mutually exclusive events, and it is written as B P A or B is equal to PA plus PB. So this is the formula. So you will be using these formula in our worked example, which is example number 8. So let us do examples, and then we'll be doing exercise 8.3, which is our last exercise, and then there are examination practice questions. So James and Sarah both taking a music examination independently. You see that he has clearly written independently. The probability that James passes is 3 by 4, and the probability that Sarah passes is 5 by 6. James passes. Now, the probability that James passes music class is equal to 3 by 4. There are 0.75% chances. There are 75% chances, in fact, 0.75% not. 75% chances that James passes, okay, and Sarah passes, is equal to how much are there? Are 5 by 6. So you see that James will not pass. I can say it that it is 1 by 4, and Sarah will not pass is 1 by 6. Now, because these are independent of each other, if James is passing, then it has nothing to do with the passing of Sarah, or if Sarah is passing, then it has nothing to do with the qualification of James. Okay, now what does they ask us? What is the probability that both pass? What is the probability that both will pass? Now this is part A, both pass. Okay. Now what is the probability that both pass at the same time? Now because these are independent events, so what we do here is We'll write both pass, and what we did for, I can say it like probability of A is J because it is James, J, J and S. Now how will you open this? This will be Pj multiplied by Ps. Okay. Now what is the probability of this is 3 by 4 multiplied by 5 by 6. Okay, now it will become uh, numerator to numerator and denominator to denominator. We'll just multiply them together. It will become 15 divided by 24. Now here is the probability that both will pass. That both will pass because this is an independent event. So as I told you earlier that now this is complete. Now for the next, as I told you that it will not pass, or it will, you can say that he will not able to qualify is 1 divided by 4. And similarly, if Sarah has is not qualified, Sarah cannot qualify is 1 by 6. Okay, now what is the probability? Is it in next? Neither passes. Okay, neither pass. Now James, if James fails, that is the probability 1 by 4. If Sarah fails, that is the probability 1 by 6. Now both fail, though both neither pass. You can say both neither pass. Now this is part B, neither pass. Okay, both neither pass. Okay, the thing will remain like this, but only the figures will be changed. Only the figure will be changed. You know that neither means, when you say neither, it is the probability. Just recap your mind that when I say not, no probability, not probability, so it is the PA. Okay, 1 minus PA. Now this is PA. Okay, 1 minus PA is this. Simple. I've already told you in simple words. So it is P of not happening. Not happening. Okay, P of not happening is equal to 1 minus PA. I'm afraid it is not visible to you. P not happening, I will write it here. Not happening, that is equal to 1 minus PA. This is our earlier formula for not happening, and I have already calculated it like this and like this. Okay, not happening, 1 minus 3 by 4 is equal to 1 by 4. Okay, if you calculate it, and the formula will remain like this. So it will be 1 by 4 multiplied by 5 by 6. 1 by 4 multiplied by 5 by 6. So it will become, oh sorry, not 5 by 6, it is 1 by 6 over here. It is 1 by 6. 1 by 6 because for not it was 1 by 4 and 1 by 6. Fail, or you can say it fail. The probability of failing are 1 by 4 and 1 by 6. So it will become 1 by 24. Okay. Now part C. Now part C is that at least one will pass. At least one will pass. Is my dear students, what is it? At least one, yes, at least one passes. So P is equal to at least one passes. So it is equal to 1 minus. Now what was the our figure which was that this was the figure which was which we got. Now my dear students, what was the probability that both will fail or what will not pass? Now The emphasis is on the word not. Okay, the not pass probability was 1 by 24, and if I say the either one will pass, that means it is, mm, again, there are two nots in this. So you can say it that P at least one will pass is 1 minus not pass. 1 minus not pass probability. So it is 1 by 24. So you just calculate it, it will become 24, or 24 minus 1, or that is equal to 23 minus 4, 24. So this is the probability that at least one will pass, and this was part C. And what is the part B? Either James or Sarah passes, not both. Okay, either James or Sarah pass. Either James or Sarah pass. Again, this is for the not of what we calculated in our first example. What we calculated in our first example. So it has also written that either James or Sarah pass, not both. Now this means that the James pass and Sarah fails. That either James pass or Sarah fails, or Sarah pass or James fails, because these are independent events. Both, anything can happen over here, regardless of what has happened with Sarah or what has happened with James. Okay, so it is very easy now. Okay, we'll keep these results with us now. We will keep these result of not passing. Okay, these are the result for James passing is 3 by 4, and not passing is 1 by 4. Sarah passing is 5 by 6, and Sarah not passing is 1 by 6. If I say that uh, James pass or Sarah fails, or and James and Sarah passes or James fails, either one will pass. Okay, now if James is pass, that is 3 by 4, and Sarah fails, that is 1 by 6. One thing is complete. James has passed, Sarah has failed. Okay, and also if Sarah has passed and James has failed. Okay, so what is the total of this? Just 24 divided 3 divided by 24 plus 24 again. So it is uh, 3 upon 24. It is 5 times 1, 5 by 24. 5 by 24. Just add these, you will get the result. That is 24, and since it is 24 and both in denominator are 24, you will just add them up. That is equal to 8 upon 24, or you can say that it is 1 divided by 3. 1 divided by 3. So this is the probability that either of one will pass and other will fail. For example, that James will pass and Sarah will fail, and Sarah will pass and James will fail. You see that here I have taken the pass probability for one and the fail probability for the second, and I have added the pass probability for second and fail probability for the first. So we'll just add them up and it will become 1 by 3. So my dear students, this is the example. So for I'm just skipping example number 9, and we'll just be heading towards our exercise. A standard cubical die is thrown. Now you see that uh, in the past experience, in the past exercise, we were given some modified dice, because some have 4 faces and some have 8 faces. Now he has specially written a standard cubical die. That means it has 6 faces, and in 6 faces there are 1, 2, 3, 4, 5, 6 numbers on them. Calculate the probability that 2 sixes are thrown. two sixes are thrown. Now, my dear students, exercise is 8.3. Exercise 8.3. And what I told you about the dice, it is the standard cubical die. Okay, it is the standard cubical die. Two sixes are thrown. Now, this is one die, but there are two throws. Two throws with one die. Now, question number A. Question number A is question number 1, part A. Okay, you can say it like this. Question number 1, part A is that two sixes are thrown. Okay, short. Okay, two sixes are thrown. What is the probability of 6? One time, that is 6. 1 by 6. 1 by 6. Now, probability of two sixes. Probability of two sixes. Okay, right, like this. Probability of two sixes is, yes, because these are independent of each other. Okay, so it will be multiplied 1 by 6, 1 by 6. Okay, so it will become 1 upon 36. Two even numbers are thrown. Two even numbers are thrown. You see, now for the first throw, now part B, how many even numbers are there? 1, 2, 3. There are three even numbers in one throw possible which can come across. There are, now this is 1, this is 2, and this is 3. And similarly for the second throw, the same number will appear. That means for one event, the probability for one event, for the probability of even number for one PE will be 1, 2, 3. That is equal to 3 upon 6. Okay, and of course this is, and for the second evens are again this is this, or you can say it that 1 upon 2 or equal to 1 upon 2. Okay, now the probability of even for the both r is equal to 1 by 2 multiplied by 1 by 2, that is equal to 1 by 4. So simple questions. So my dear students, C and D are same like this. Um, a bag contains 12 colored balls. Now question number 2. C and D are just same. You can do it. And if you feel any difficulty, you can ask me. Always ask. You have noticed that whenever a student has asked, I have arranged a special lecture watch. Okay, so you can ask anytime. Question number 2. I skip the questions because to save time. Okay, a bag contains 12 colored balls. 5 of balls are red and rest are blue. Okay, now a bag contains 12 colored balls. Now this is a bag. This is a bag and it has how many balls? 12 balls. There are 12 balls in it. 5 of the balls are red. Now 5 of are the red. Now this is red, this is red, this is red, this is red, and this is red. Okay, and what? And the rest are blue. Now this is blue, this is blue, and this is blue, this is blue, this is blue, and this is blue, and this is blue. Now how many are red? 1, 2, 3, 4, 5, which is given. Reds are equal to 5, and blue r is equal to 7, because in total there are 12 balls. In total there are 12 balls. A ball is drawn at random from the bag. It is then replaced by this second ball. It is then replaced. Now what thing? One thing which is very important in this question is the replacement and without replacement. Is replacement and without replacement. Okay. Now let me tell you what is replacement and without replacement. and without replacement, okay. Now for example, there are some draws. For example, you have to select a team. And you have uh, put some chits, folded chits, in a cup or in a bowl. And for example, you want to just shuffle them, and there's a team you have to select of five players. Now what do? You just pick a chip from here. Okay. Now what happens, my dear students? Just note this point very carefully, that when you pick one player from here, because this is a chit of any name, a named chit has been written, so I can say it, just pick a player. When you pick a player from here, for example, Azam has been picked. From here. Now we will not replace it back. When the Azam has been chosen, we will not replace it back, because in the team of five, it is possible that Azam will again and again appear. For example, it has appeared for 3 times. What will you do then? So, when the Azam has been picked up, you just throw that chit from the board. You will not replace it back. Okay. And for the second time, you just pick what was Babar. So you just pick Babar for the third time and just thrown that chit. You just Zaman, you just pick Zaman, and so on and so forth. And you are picking without replacement. You are not replacing it back. But for example, if there is another scene, another thing, now again the ball and the kids or the balls or whatsoever it is, you are picking one item out of it. You just see that item, and after using it, you just put it back. It is with replacement. Okay, it is with replacement. When you put the thing back to its original position, then it is with replacement, and what I told you before was without replacement. So this is the thing which is with replacement. This event is with replacement. Okay, event with replacement. So what is our question? The ball, 12 colored, 5 of balls are red, and a ball is drawn at random from the bag. It has been replaced and second ball is drawn. Now, first you have picked one ball at random, put it back, and then you have again picked another ball. The second ball. The color of each ball is recorded. Now, A. What is the list? List the possible outcomes of the experiment. Need this the possible outcomes of the puzzle. Now you can do it manually. Now, for example, you see that first your balls are red and blue only. So there is a chance that you pick a ball which is red. This is the first event. And this is the second event. Okay. Now for the you picked red ball and you picked again red ball. You picked red ball in the first event, you replaced it, and again picked the red ball at even blindfoldly. You can say it blindfoldly, and you pick the red ball again. Second. Now this event is okay. Now you will not repeat this event again. Now, for example, you pick red ball and then blue ball, and you picked red ball and blue ball. Okay, it was blue ball. While I was writing right, blue ball. Okay, red ball, red ball, red ball, blue ball, and blue ball. Okay, for the fourth, you are going to pick blue ball and a red ball. So these are the possible outcomes. So these are the possible outcomes, which is red in the first event, red in the second, red in the first event, blue in the second, blue in the first event, blue in the second event, blue in the first event, red in the second event. Now these are the possible outcomes in four events. Either you pick red ball or you pick blue ball. Okay. Now how many events are there? Now for the first there are two possible events. The red ball will appear. Now what are our questions? The questions are, let me rub this and we'll be doing question. The first ball is blue. The first ball is blue. Now this is B1. So the B1, we'll be doing B1. The first ball is blue. Now you see that first ball is blue here over, and this is the first ball is blue. Okay. Now how many balls are there? How many balls are there? There are 12 balls. There are 12 balls. So the first ball is blue. That means, and you also know, let me write here. Let me write here that how many red balls are there and how many blue balls are there. Just to remember this thing. Okay. Just to remember, red balls were five of the balls were red. Okay, so these were the five and these were seven. Okay, out of 12, because these were 12 balls. And so the first ball is blue. Let P, the first ball is blue, is equal to how many balls are there? Seven. Okay, and how many are in total? Our favorable outcome is seven. It is it is chance. The 7 out of 12 balls, 7 out of 12 is the probability that the first ball will be blue. Now part number 2, it was quite easy. The second ball is red. The second ball is red. Now you see, the second ball is red. Second ball is red, is 5 upon 12. Okay, this is just the first ball is blue and second ball is. Now this is the question. The first ball is blue. The first ball is blue. First is blue and second is red. How will you do it? So we have already done first ball is blue and second is red. Okay. Now what will we do? We'll just multiply the whole thing together, because I have told you how to uh, calculate the probability when two events which are independent of each other. So how we will calculate that? So P of blue, first blue and second red is equal to, this is first blue and multiplied by second red. Okay, now this will become 35 divided by 144. 35 divided by 144. Now, uh, two balls are of the same color. Two balls are of the same color. You see that here there are two balls of the same color, and here there are two balls of the same color. So how will we do it? 3, 4, two of the same color. P, two balls, two balls, same color. That is equal to. Okay, two balls are of same color. Now you see what is the probability of here. Here it is red ball, and red are how many? 5. 5 divided by 12. Again red. This is 5 divided by 12. Okay, that means first ball uh, and the second ball are of same color. First ball and the second ball are of the same color, and also we have one more event in which both the color are same, and that is 7 upon 12, because this is blue, and blue, the probability of 1 is 7 upon 12, so it is 7 upon 12 again. Here, from here it is 5 upon 12, 5 upon 12, and from here it is 7 upon 12 and 7 upon 12. Okay, now just uh, simplify this. It will become 144, 25, and plus 144 again, and 49. Okay, understand? 7 7 times 49, 5 5 times 25, 12, 4, 12, 12 times 144 in both cases. Now, since it is addition, let me erase the whole thing from here. So it will become 144. You see, it will become 144. The LCM will be 144. It will become 25 plus 49. Okay. Now it will become 4, 7. 74 upon 144. So this is your probability that the two balls will be of same color. Okay, my dear students. The two balls are of different color. Two balls are of different color. It is very simple now, since you have calculated this, then it is very much easy for you. Now that means, in other words, that means they are not equal colors. They are not same colors. When you say not, then we have to just subtract which is the probability from 1, which is the probability. Now, this was the probability that these are of the same color. Then if I subtract it from 1, then it will be not the same color. Here we are and here we are. Okay. Now, you can do it in different manner also. Let me try it. Let me try it. Okay. Now, P not, what is it? Different color. Not the same color. It is, in other words, not the same color. You can say not the same color, because in your book it is stated that they are a different color. They are different color, different color, different color. Now, different color means that they are not the same colors. Is it one or the same thing or not? Not the same color or different color. That means 1 minus 74 upon 144. That is equal to 144 will be our LCM, and 144 will come over here and 74 over here. Okay. Now, I may use calculator now. It is 144 minus 74. 70. Now that is equal to 70 divided by 144. Two balls are of different color. Neither ball is red. Neither ball is red. Okay, now neither ball is red. Our next part is neither ball is red. Our neither ball is red. B part is fifth. Okay, neither ball is red. Neither ball is red. Now, how many events are there in which there is red ball missing? You see, here we have red ball, here we have red ball, here we have red ball. Okay? Now, neither ball is red is only in one event. Neither ball is red is only in one event, and that is the fourth event, the third event. Okay? It is the third event. It is the third event. And fourth is this. Blue and blue, because there we haven't any red ball. So neither ball is red. Neither ball P, no, neither ball is red. Okay, neither ball is red. That is equal to, now you see that we have red ball here, we have red ball here, we have red ball here. And what was the probability of blue ball? The probability of part 1, okay, that was 7 upon 12. And again, it is 7 upon 12. It is again 7 upon 12. Neither of other uh, mm, combination has is free from the red ball. Now this has red ball, this has red ball, and this red ball. So we cannot take into consideration any of the three. So only and only we will take this one. So it will become 49 divided by 144. Okay. Should I leave one question for you? At least one ball is red. At least one ball is red. Now B6-7. I At least one ball is red. At least one ball is red. Now here we are. At least one ball is red. Here at least one ball is red. That means this, when we subtract this from one, the rest will come in our at least one ball. One ball is red. One ball is red. Okay, at least one ball is red. So this is 1 minus 49 divided by 144. So this will become 144, and 144 minus 49. This sort of questions can be done in another way. Okay, can be done in another way, because you see, at least one possibility was here, and one possibility was here, and one possibility was here. So you can do it in another way, but this is far more easy to do it, and it is more easier when you have already solved this part. When you have already solved. Okay, now my dear students, let me start question number 3. Interesting question. Devin and Taj are playing card. Devin draws a card, replaces it. Now you see here again, they have clearly written that he replaces the card. This means the events are with replacement. Replaces it and then shuffles the pack. Tate then draws a card, find the probability that both draw an ace. Question number 3, part A. Both draws an ace. I have already told you in the beginning of my probability lecture that there are 52 cards. Now, total number of cards, let me write it on the rough side. There are 52 cards. Okay, there are 52 cards. Colors, two colors, red and black. Okay, in this, in each of the color, What we have? Red is hearts and diamonds. And in black, we have spade and club. Okay, there are aces. In each of the category, there is one ace. Now there is one ace. Ace means A. Okay, there is ace. Now how many ace must be there? Aces. The plural is aces. Aces are four. One from each. Now what does it mean? There are 13 cards in 13 card, 13 card and 13 card. Out of 13, there is one ace in each, and the aces obviously are four. Kings, four, because four categories. Queens, four. Jacks, four. Okay, now we can uh, do a both draw and ace. Both draw and ace. What are their name? Their names are P, Devin and Tay. T, D and T, I can write it, D and T. That means both draws an ace. Now, how many aces are there? There are four aces. Is the probability of one ace is four. Okay, of drawing. The probability of drawing an ace from the deck of cards is 4 divided by 52. Is 4 divided by 52. He has replaced it back, so Tej will also pick the card and the same uh, is ace. The event must be ace. So it is 4 upon 50, 52, because how many aces are there? 4 aces out of 52 cards. 4 aces out of 52 cards. And similarly, Tej will also uh, have the same probability, 4 out of 52. So it is very easy that it comes 1 upon 13 and it will become 1 upon 13. So the net result will be 1 upon 169. 13 times is 169. Okay. Part B. What is part B? Board draws king of hearts. King of hearts. King of hearts only. Okay. That means king of hearts. King of hearts. Here we have king of hearts. There are only 13 hearts. And the next part is B. The board draws king of hearts. Hearts. No, hearts is like something like this. King of hearts. Red. This is red in color. This is red in color. So what they have done is, because in a deck there are how many cards? 52. So possible outcomes are 52. Possible outcomes are how much? 52. And how many kings are there? How many kings? Is it kings? Yes, kings. How many kings are there? There is only one king of heart. There is only one king of hearts. So this is for the Devin. What was the name? Yes, Devin. And similarly, the same probability will be for Tej. Okay, so this will become 1 divided by, now this is the square. Oh, it will become 2704. 2704. 52 square is equal to, yes, 2704. Similarly, Part C. Part C. What does Part C says? Devon draws a spade and Tage draws a queen. Okay. Now Devon has drawn. Devon has drawn what spade? Spade. And Tage has drawn queen. Now how many cards of spade are there? 13 cards. And obviously, when there are 13 cards, the probability will be 13 divided by 52. The probability will be 13 divided by 52. And Tej has drawn queen. Now, how many queens are there? There are 4 queens. 4 divided by again 52. So, this must be the result. 52 divided by again the square I have already done. So it will should become, now this is again divisible by, so it should come like this, 1 upon 52. Now part D. Now my dear students, question number 3 part C has been completed. Now part D. Now what does part D says? It is a logical thing. He says exactly one of the card drawn is heart. Exactly one of the card drawn is heart. Now what does it mean? It means that, for example, if Devon draws it, it will be a heart. It will be a heart. Let me erase this one. Now, part D says that if Devon draws a heart, Devon draws a heart. So, what does it means? That the probability of Devon drawing a heart, or drawing a heart, is equal to, how many cards are there? There are 52 cards. Okay, and hearts are how many? There are 13 hearts, and of course, each category has 13 cards. Each category has 13 cards, therefore, heart is also one of them. Therefore, heart has 13 cards. So, it means that the probability would lie like this, that he will draw, but the game is not finished as yet. What is the book saying is to you is exactly one of the card drawn is heart. One of the card drawn, exactly one of the card drawn is heart. No, that means, now this means that if he draws a card, the probability will be 1 by 4. And at least one card drawn is heart. That means Mr. Tej has not drawn it. Mr. Tej has not drawn it. Okay. Now let keep this result with us. Now if Tej has drawn it, Tej drawn a heart. What I'd say here, that when Devin draws a card, Tej didn't, and when Tej will draw a heart, Devin didn't. Okay. Now this is the point. This is the logic over here. This is the logic over here. Now P, that Tej drawn a heart, is equal to, again same, because 13 red hearts and 52 cards. And 52 cards, it will be 13 divided by 52, and that is equal to 1 by 4. Now what is, now you see that Tej drawn heart is 1 by 4, Devin drawn a heart 1 by 4. Now when this thing Let me give it a number. Now this is number 1 and this is number 2. Okay. Now in number 1, the logic is when Devin has drawn a card, heart, that means the other person will not draw heart. The other person, which is stage, will not draw heart. That means the not probability is P that Tej has not drawn a heart. Let me do it with this one. Tej has not drawn a card is equal to 1 minus 1 by 4. That is equal to 3 by 4. And similarly, for this part, when probability will be that Devin has not drawn a card is equal to 1 by 4, that is equal to 3 by 4. Okay, now accumulating these results. What will happen? Now what will, because you see, I am going to repeat it again and again. When Devin has drawn a heart, Tej has not drawn a heart. When Devin has drawn a card, Tej has not drawn a card. When Tej has drawn a card, the Devin has not drawn a card. Okay? Because this logic is given into your book in question number 3, part D. Now, let me proceed. Let it be written like here. Okay, I hope you would have understood. So I have to erase it. Okay, now. What is the probability? Accumulating the probability that at least one heart has been drawn. One heart has been drawn. Exactly one of the card drawn is heart. Exactly one of the card has been drawn is heart. One heart only. One heart is equal to P of one heart. Okay. Now it will be like this: 1 by 4 multiplied by 3 by 4, because only one possibility was there. One heart probability was there. So it is like this, and this finish for Devon, and this finishes for Devon, and what starts for Tej now. Now similarly it will be like this. Now here the Devon has the probability of the card and Tej has not. Tej has a probability of heart and Devon has not. So it will be like this. It will be 3 divided by 16 plus 3 divided by 16. Okay. So it will become 16 will be the LCM, and 3 plus 3 is equal to 6 upon 16. Okay. So it will be further simplified to 3 times and to 8 times. And the total probability that only one card of heart has been drawn is 3 by 8. How simple, but how tricky. This was how simple, but how tricky. So my dear students, question number 3, part E. What does it say? Both cards are red or both cards are black. Both cards are red. Both cards are red or both cards are black. We have seen that there are how many red cards? There are 26 red cards in total, and 26 red cards, black cards in total. So what is the probability that it is red and blue? Red and blue. Both cards are red or okay. Now both cards are red and both cards are blue, black. Red plus black. Okay, red plus black. That is equal to, now Tej has this probability. Tej has this probability because there are red cards. There are 26 red cards out of 52, and obviously uh, Devin, or you can say that Devin. So this is Devin and this is Tej. Okay, so this is again, both has picked red cards. Both have picked red cards. And similarly, DT, now you can say it like this. Both have picked black cards. Both have picked black cards. So this is a similar sort of figure. Because here they are fetching red card, both of them, and here they are fetching black card. So it cuts to be 1 by 2, 1 by 2 plus 1 by 2 and 1 by 2. Okay. Now what happens here? You see 1 by 2, it is left with 1 by 2 multiplied 1 by 2 plus 1 by 2 and multiplied 1 by 2. What happens? It will become 1 by 4 plus 1 by 4 plus 1 by 4. What happens? That 4, 1 plus 1 is equal to 2 by 4. That is equal to 1 by 4. 1 by 2. The probability of that both are red card or both are black card is 1 by 2. The cards are of different color. The cards are of different color. Card number F is again similar to this because they both are of different colors. Both cards are of different colors. The cards are of different colors. Same. The same logic will apply over here. So need not to be done. Now, question number 4. It is the last question of this exercise, and then I'll be wetting this video and I'll upload this video. Okay, Kirti and Justin are both preparing to take driving tests. They each learn to drive separately. Separately, so the result of the tests are independent. Now the condition you can hear that tests are independent. Okay, the results of the tests are independent. The probability that Kirti pass, the probability. Now probability is also given. Probability that P of Kirti, say PK, passes is, now this is the probability that Kirti will pass. Okay, the Kirti will pass is 0.6, and what else? And Justin passes is P that Justin will pass is 0.4. Okay, now these two things are given. Probability is given. P that K will pass, Kirti will pass is 0.6 and Justin will pass is 0.4. Now what is their question? Both pass the test. Now both pass the test is, obviously they have both passed here. That means P, K and J. P, K and J both pass over here. So it will become 0.6 multiplied by 0.4, that is equal to 0.24. Now both will pass. The probability here is 0.24. Okay. Part A finished. Part B. Neither passes the test. Okay. Neither passes the test. Now P, K and J. Now I am going to push a dash over here. Okay. Complement. K complement, J complement, that means both of fails. So when both of fails, that what does it mean? It means that fails Pk. Let me do it separately. Pk is equal to 1 minus 0.6, that is equal to 0.4, and Pj dash is equal to 1 minus 0.4, that is equal to 0.6. Now you see the probability has been reversed. The probabilities has been reversed. The probability of passing was zero point 0.6 over here and failing is zero point 0.4. The probability of passing here is zero point 0.4. The failing is 0.6. So what will be here? Again, results are over here with us. So it will become zero point 0.4 multiplied by 0.6, that is equal to again 0.24. It is again 0.24. Now Kirti passes but Justin doesn't pass. Now next is, now this was part B of question number 4. Yes, question number 4 part B. Now question number 4 part C. Pk is equal to 0.6 and Pj is 0.4. Okay, this is given to us. Okay, now part C. Part C. The part C is Kriti passes but Justin doesn't pass. Okay, now that means Pk. Now this is the probability that you to pass and this is the probability that Justin fails. Complement. I have taken complement because he says that Kriti passes the test but Justin doesn't pass. Kriti passes the test but Justin doesn't pass. That means our passing of Kriti was 0.06. That was 0.6. It was 0.6. And in our last part, we just calculated the fail probability of Justin. So it was, you see, you can also calculate it from here. When it is 0.4 of passing, the fail is 0.6. You can write it here as well, is equal to 0.6. Okay, now for this, it will go like this because these are like this. Probability of Kriti will pass and probability of Justin will fail, that is equal to 0.36. Okay. D. Exactly one, no. D. At least one of Kriti and Justin will pass. At least one of Kriti and Justin will pass. Now, it is that one will pass and other will fail. Obviously, when one will pass and other will fail, this is the logic of this question. At least Kriti or Justin passes. Or Justin passes. So it relates to our part number. What was the part? It was part B. It relates to part B. So how does it relate to part B? Because we are given with this, you see that at least one of the paths. It is 0.6 and this is 0.4. When this is 0.6 and this is 0.4, the collective will be the answer of part B. Keep that answer, part B. That was 0.24. You remember that it was 0.24. Now, for example, now keeping in this, or you can do the procedure over here again. Part B, first you just repeat the procedure of part B and then we will get ahead. So it will be at least one will pass. At least Kriti or J passes. K or J. Okay, K or J. So it will be like 1 minus 0.24, that is equal to 0.76. And E, the last part and the last of the, exactly one of the Kriti and Justice passes. Okay, now it is very easy again. So you see again, you must have been keeping the preceding answers. So you see, when Kriti passes, K passes, J fails, or vice versa, and vice versa. Mm, K fails and J passes. Now this is our, so it is like this P, and we'll, because this is K and J, so vice versa is equal to, now you see, when K passes, it is given K passes, J fails. J fails is zero point 0.6 plus K fails 0.4. Here the fail probability is this. Fail probability is 0.4 pk dash. Okay, and the passing probability of J is 0.4. 0.4. Okay, so it will be like this. 0.36 plus 0.16. 0.16. Okay, add them up. 0.36 and 0.16, that will be equal to 2 and 52. So it is equal to 0.52. That one of the Kriti will pass, J will fail, or J will pass, Kriti will fail. Okay, now this is our whole story for the probability, and we'll be meeting in our next examination paper questions very soon. Examination practice questions very soon. So this will be our last exercise of probability, and then we'll proceed to our next chapter. So it's time to say you goodbye, my dear students, and keep on watching my lectures in physics and in mathematics.